Okay, so welcome. Happy teaching block 2. So this is virtualization and cloud computing. If you haven't had a class with me ever before in your lives, my name is Vasilios Adamos. I don't expect you to remember the whole Vasilios business, so you can just call me Vas or you can just call me Vasily, whichever one is easier for you. I live in A2.net, which is the lab, the networks lab on the second floor of Anglesey building. I do have an office as well, but I'm almost never in it. It's an A202B. And the best way for you to contact me is to either come and find me in the lab, because I'm there all the time, or just send me an email and I'll get back to you in due time. Now, I am recording this because it is Monday morning, 9 o'clock, and I've already had 4 email replies to my email from yesterday saying, can we move this to another time, blah, blah, blah. We cannot, unfortunately. There's too many of you. There's 130 odd of you. So we need a big lecture theater, and it's a regulation or a rule now that we have to have all lectures on premises, okay, face to face. I will record this. I will test the quality of the sound and image and everything once we're finished and I go home. And if I see that that's fine, then I will upload it on my YouTube channel, and then you can just go and see it. And I will link it on Moodle as well. Okay. So today is the intro lecture, so I will explain basically how the module will run for the rest of the semester. We'll start with what events are timetabled. So there is weekly lectures. So every Monday morning, 9 o'clock, we'll have a lecture during which I will explain the theory behind what you will be doing in the labs, everything that's in the lab sheets. Now we have about 10 lab sessions for this module. We don't have 10 lab sheets. I think the lab sheets in total are about 6. Okay. This means that we don't need to have a lecture every week. So for example, the first 2 lab sheets, which are on VMware and VirtualBox, are supposed to last 2 weeks each. So we will have a lecture next week where I will explain VMware, but we won't have a lecture the week after because that will be the second week of VMware. The week after that, which will be the first week of VirtualBox, we will have a lecture. The week after that, we will not. Anyway, as I probably mentioned in my email yesterday as well, if we are not to have a lecture, I will let you know by email so that you are sure whether you need to come in or not on the following Monday. Okay, and I will let you know by the end of the previous week. Okay, so 1 hour lecture, and we'll have weekly 2-hour lab sessions. So on your timetables, you should be in a slot in the lab in A2.net starting from next week. That will either be Monday at, I think it's 2 to 4 and 4 to 6 in the lab sessions, or Thursday, which will be 9 to 11 or 11 to 1. Okay, I would like you to please come on the allocated time slot in the lab. Okay. There's about 130 of you, I think it's 136. The lab fits 48, so I can fit 144 students in total. So out of the 4 lab sessions, I will only have 8 spaces spare. If you start moving around, somebody will be left without a computer. Also, if you move around and don't come to your allocated lab session, then attendance will not work for your student ID. And then you start getting those annoying emails from the university saying, you haven't engaged with this module, why? All right. If there is an extremely serious and important reason, like you work or whatever and so on, and you cannot make it to your allocated lab session, I can probably try and change it, but I cannot guarantee. Okay. It would be much easier if, for example, you found a student that's on the lab session that you want to move to, and they want to move to your session, and then you can swap. So that would really be the best. Anyway, what I will try to do is when we come into the labs, because the computers that you work on are allocated, so you're supposed to sit on one computer and then continue on that computer for the rest of the teaching block. I will sit you all, and then we can decide whether you need to move or where you're able to move at the end of the week. So once I have the seating chart for everybody, and I can see exactly how many students I have in each lab session, and if I do have spare computers to move you around, then I will. All you need to do on your part is, when you do come to the lab, tell me that you are interested in possibly moving to another slot. Okay, because then I can sit you on a specific computer that might be free. So I always sit students in I start from specific sides of the labs, depending on which session they're in, so that I know where everybody is starting from. Okay, so the first session on Monday afternoon, for example, I will start sitting them from the far left corner of the lab. Okay, so make sure that you know which lab session you're in, and make sure the first week you definitely come to your allocated lab session and not the one you would want to be in. All right, so the assessment for this module is through Logbook and exam. They're both worth about 50% of the module, so it's equally important to do well on both. And all of the notes that you will need about it will be on Moodle. At the moment on Moodle, you will be able to see the module because I unhid it yesterday, but you should only be able to see the first week. So this week, I will go through my lab sheets and make sure that everything is working correctly, because I'm using newer versions of software than last year. And once I sort everything out and test the labs, I will basically reveal all of the lab sheets for the entire semester. This means that if you're good at this and you want to, you can move at your own pace and you can move forward beyond what I've explained and everything else. Okay, so the pace during which you're working is totally up to you. The only thing that I would not recommend that you do is leave everything, do nothing, wait until Easter, and think that you can tackle the whole thing, in a couple of days. If you know Linux very well, and you've used Open Nebula before, you probably can. Okay. However, it's a big risk. People have done it in the past, and in fact, last year I had a student who was fairly good, generally, tried to do this and failed miserably. So it's a bit of a risk, yeah? The best thing that you can do is to actually come to the lab sessions, see how we're progressing, see how you are moving on and everything. So for example, if you come in the first lab session and do the VMware lab sheet, and you go through all of it in one go, and you want to take a break the next week and don't come in, don't come in. Okay. Or you can come in next week and make a start on the next lab sheet, which is VirtualBox, on your own without me having explained everything. As long as you think you understand what's happening, then that's fine by me if you move forward as well. Okay, but it's important that you actually do come to the lab, because then me and my lovely teaching assistants, of which I have plenty this year, will be able to help you out with anything you need. If you come in and work on your own, then there will be nobody there to help you, so it's not a very good use of your time, really. If you are going to spend time in the labs, make sure you spend the time in the labs with us there as well, so that we can help you as well. The lab itself, it's a2.net. Hands up if you've never been to a2.net before. Okay, I hear you, that's fine. So Anglesey building, second floor, all the way on the left-hand side as you go up the stairs. It's a very big lab. It has 2 doors. We keep the 2 doors there for fun. Everybody tries to go in from the door on the left, which is always locked. It's the door on the right side that you need in order to get into the lab. Yeah? So once you're in the lab, you will have 2 hours per week, which is your allocated time in the lab, and then you can come and use your computer on an open access basis. This means that the lab is open from 8 o'clock in the morning until usually 8 to 9 o'clock in the evening. Okay? And as long as there is no other class running in there, you can go in and use your computer as you like. Even if there is another class running in there, as long as your computer is free and you ask permission from the lecturer that's teaching in there, 90% of the time it's me, and you set your phone to silent and you don't play loud music through your headphones, you can come in the lab and work. Okay, and if you have a problem, we might even help you as well. All right, so the lab is there for you to use. You will always be sitting on the same computer. You will always log in with the same username. So essentially, you build it and it's your own computer away from home and you're responsible for it. All right, and you can come and work on it whenever it's actually free. We have 1 student per computer, of course, so it's individual work, it's not group work. Of course, we expect you to help each other in the lab. Okay, If you're stuck with something and you can ask your friend that's sitting next to you or something like that, it's fine. We have no problems with that. If you feel like you're progressing fast enough and you want to help some other people, you're free to get up and go around and help some other people. That's perfectly fine. Okay. The only thing that we don't want is, on a first level, same screenshots. So you're working in the lab and you're documenting all of your work in the lab onto a logbook. Okay. Documenting your work means that you're keeping screenshots of the work that you've done. Those screenshots should be different for every computer in the lab. Very similar, because you're doing the same stuff, but they shouldn't be exactly the same. The second level of this is the screenshots require lots of theory and explanation underneath them. The idea is that you do the work, you take a screenshot as proof of your work, any configuration changes you made, any testing that you've done on the material that you've done in the labs, and then you include this screenshot in your logbook, and you explain under it what you did and why. The why is the most important of all. Okay. So, the wording underneath must not be the same. Of course, you will say, wake up. Of course, you will say, there's 130 of us, how will you know if we're copying off each other? Annoyingly, I'm a bit of OCD and, I can remember things. Plus, I look at all your logbooks pretty much in the same week. So last semester, I had about 6 MSc students that had the same logbook. And I sent them around to do it again. Okay. Apparently, they hired the same person to do it for them, and it was really stupid. Didn't do it differently. So, yeah. Okay. So, it's better for you to try and do everything yourselves rather than get a lot of help for it and not actually learn anything from it. Because then the second component to this whole business is the exam. In the exam, it's a computer-based test on Moodle. If you don't know what's happening, then you will not do very well. Okay. And also, more annoyingly, the exam itself is an open book. So it will allow you a double-sided page of A4 in the exam. Yes, so you can bring your own cheat notes and everything. However, if you don't know anything about what's happened in the labs, even the notes will be useless. Okay. You will get allocated computers and user accounts. So every time you come into the lab, you need to sit on the same computer and you need to log in with the same username and password. You will basically be VM5, VM6 people that are working on Monday and VM7, VM8 people that are working on Thursday mornings. Okay. You must make sure that you always log in with the same account. And the first time that you log in next week, I will ask you all to change your passwords. This is very important because if you don't change your password and you leave it to the default system password, which is localhost 1, somebody else can accidentally or on purpose log into your account and make changes. You don't want that. Okay, so first week we're in the labs, you're going to change your password. I don't believe I have to say this. You need to change your password to something that you will remember. Yes? Annoyingly, in the previous semester I had about 20 students that came in the second week and couldn't log into their computers with the password that they had set. Okay. The best practice is to set it to the password that you're using for your university account. Okay, in order to log into Moodle, your Gmail account or whatever it is. All right. And kind request, because there is a lot of you in the lab, try to keep the lab as tidy as possible. Okay, so try to put the monitors back in their place, straight, keyboard straight and everything. Don't leave any garbage, especially on the floor. The cleaners don't really go in that lab that much. So if you do throw something on the floor, I will be the one that has to pick it up. And I, don't really want to work as garbage man. Yes? Also, something that I've noticed this year. When you're finished, don't just run off your desk and leave the chairs everywhere. Just push the chair back under the desk. Again, because this just messes with my OCD. Yeah? It's a kind request, please. Thank you. The logbook. It's an electronic logbook. The best way to do it is to go onto your Google Drive using your student account and create a Google Doc. name it VCC Logbook and then your student number, and then access it on the lab and work on it when you are in the lab itself. It should be kept during the practicals, and it will be submitted at the end of the semester. If I remember correctly, the deadline for it for this year is the 11th of May, which will be the Thursday of the last week that we're in the labs. Okay, so it is an assessment that runs the entire year. You need to start working on it as soon as you start working on the computers themselves. So you should be completing it in parallel. So the first thing that you need to do when you log into the computers is to actually go to your Google Drive, create a doc, and then actually start working on the computer. Take a screenshot, take a snapshot with the snapshot tool that we have in Linux, stick it in the logbook. Even if you don't want to explain stuff, just make sure that you get the screenshots, put them in the Google Doc, and fill in all of the details later when you go home. Basically, it will all depend on how fast you are progressing in the lab. Okay. Now, there is a detail about this. In the lab, you will be working inside a virtual machine. So there is a virtual machine that's called Prometheus that I've already built. So when you come into the lab, you'll have to basically extract it from the zip file and start it up and log in. Because it's a Google Doc, it works best on Google Chrome. I have Google Chrome installed inside the virtual machine. Okay, so the best thing that you can do is come into the lab, log in as VM5, 6, whatever it is, start up the virtual machine, full screen the virtual machine, because you will truly never need to do anything outside it, especially for this particular module. Okay, open your browser in there. The browser there already has Moodle as a shortcut, as a bookmark on the top left corner. Go to it, log in, and then log into your Google Drive as well. Start it up, follow the lab sheet, and work. The monitors are pretty big in there. Okay, so the best thing that you can do is have the lab sheet and your Google Doc open on the half side of the screen, and then work on your virtual machine on the other half side of the screen. If you open the logbook inside the virtual machine, you'll be able to copy your screenshots and everything else that you need to copy into the logbook straight away without any problems. More importantly, you'll be able to copy commands from the lab sheets themselves. And in fact, some of the lab sheets have many commands, and I will create text files on Moodle that you can open. And they are pure text, not copying text from a PDF file, for example. And you can just copy the commands and paste them onto a terminal, and that will make your life much, much easier. Okay, if you have your logbook open outside the virtual machine, as lots of people tend to do, then you won't be able to, for example, click on links and download stuff, and you won't be able to copy and paste commands correctly into the terminal. Okay, so I really, really highly recommend it that you start your logbooks and your, what is that? Anyway, never mind. Start your logbook and everything else inside the virtual machine. So full screen, the virtual machine as soon as you go in, and do all of your work in there. Okay. The logbook itself, I have a specific structure for it that I prefer. Okay. Preparatory work, methodology, and everything else. If you want, you can follow this. It will just make it easier for me to mark it, really. If not, you can just follow the methodology of the lab sheet itself and just fill it in any way you like, any way you prefer, as long as there is some meaning to it, basically. All right. I will check the logbook. So yes, so the way that I assess the logbooks is on the last week. So that will be the week starting the 9th of May or whatever it is. I will get you all in the lab. You will all sit on your computers, open your logbooks, open and start up your virtual machine with all of the work that you've done in there. And I will go around and sit with each of you for about 5 minutes, read through your logbook, check the work on your computer and make sure that it's the same IP addresses and everything else. If I do find something in the logbook that is too good to be true or is not the same as it is on your computer, I will ask you about it. Okay. And this is how I will basically assess the logbook. I will give you a mark for it right there on the spot. We then you then have to submit the logbooks because we need evidence of your work on Moodle, and the deadline for that will be at 11 o'clock on the 11th of May at night. Okay, I will explain the process of how this all works and what happens if you don't come to the demo session, or if you don't submit your logbook at all, or if you don't submit your logbook on time and so on. I will explain it closer to the time. The exam itself will run during the exam period in May, so after the 13th of May or whenever it is, for those 3 weeks that we have there. It's going to be a computer-based test. It will last 1 hour. It will be 50 questions in 1 hour. The questions are all very quick, and there will be different types of questions, multiple choice, multiple response, fill in the blanks. You won't need the calculator for any of them, and that's pretty much it. Okay, it will be based on everything that we've done in the lectures and in the labs. There will be nothing in the exam that doesn't exist in a perfect logbook. Okay, so if you've done all of the tasks in the lab sheets, then you should be able to pretty much ace the exam as well. Okay, and as I said, it's open book too, so that should help. That should give you that little extra boost if you actually know what's happening and you just forgot a command or something like that. So what we will be dealing with in this module is virtualization and cloud computing. So we'll basically start from the most basic of principles of what is virtualization. So the idea behind creating devices in a network or in a system that don't actually physically exist, but they really exist as software and we can use them. So whether that's an entire computer, so an entire virtual machine as we call it, that you can start up, log in, and do your work on it, just like the Prometheus virtual machine that you will be using in the lab, all the way to just creating virtual resources online, like CPU power, or amounts of memory, or amounts of hard drive space, and so on, that you can use in a system in any way that you might possibly want to use. Why is it useful? So because we can run multiple operating systems at the same time. So you can have one server and it can have lots of virtual servers inside it, because you might need to be running different services that need to run in specific operating systems. So you might have something that only runs in Ubuntu, for example, and doesn't really run anywhere else. So you can start up a virtual server running that, provide that service to your network. And you might have, for example, authentication through Windows Active Directory, and you might just need the Windows Active Directory server for all your users to be able to log in, and so on and so forth. So this is a very big benefit because you can run whatever operating system, and you're not limited with regards to the actual software that you can use in your system or in your network. You have easier software installations because, if something fails or something goes wrong, you can just start from the beginning without having to rebuild everything completely. It's good for testing and disaster recovery because they're virtual machines. You can have backups of them. If something goes wrong, you can spin up another backup straight away and everything just works. And it helps in infrastructure consolidation. So instead of having huge warehouses of servers, you can have smaller spaces with powerful server racks that can run tens or hundreds of virtual servers inside of them. And then you don't need so much power for electricity, you don't need so much power for air conditioning, you don't need so many air conditioning units, you don't need so much space essentially. So what is cloud computing? So the evolution of this is the on-demand availability of computer system resources. So especially, for example, data storage and computing power, so hard drive space and CPU power, without direct active management by the user. So you might have a researcher somewhere in a university, and they might need to run something that is very power hungry. So they are using a machine, which is a virtual machine in this case, and they can temporarily up their CPU power. So instead of using one core for the virtual machine that they're using, they can select to use 10 CPU cores and then have maybe whatever simulation they might be running run much faster for that time that they're using. Okay, so you can have benefits like this because it's a system that is not fixed and you can make changes as on a need-to-go basis, basically. Why is cloud computing useful? So it provides efficiency, accessibility, cost saving, security, and disaster recovery. So features that if we were dealing with actual hardware devices would probably cost a lot of money and would be very time-consuming in order to put into place as well. So if something went wrong, you'd have to go and buy another device for the server that's broken down, a power supply, hard drive, whatever it is. So we can do away with pretty much all these things. So the system can recover much faster and you can have much less downtime for the services that you're providing to your users. It provides flexibility, so scalability, tool selection, cloud options, and control choices. So if you're doing something, so if your business is a specific type of business, and then you need to add something to it, you need to add a feature, you need to add a service that you need to provide to your users. That service, let's say, runs on a different operating system. Again, as I said before, you can make any changes you want to the software itself, because it is all run on software at the end of the day, and you can make your changes very quickly and usually much cheaper as well. And then it gives you really a strategic edge if you're in a company, because it provides increased productivity, automatic software updates, competitiveness, and increased collaboration. So because you are running the cloud and all of your users are just the end users of the cloud, then they don't really have to deal with the infrastructure itself, you can manage their use of your system much better, because you are more in control of all of the computing resources that they're basically using. And if you need to make any changes, you can make the changes very fast. If you need to implement some sort of policy, let's say with access or usage of the system, then you can implement those changes on the fly very quickly and efficiently. So for example, the cloud that we will be using is Nebula, so it's an open source system, okay, and everything on it happens either on a command line, if you're really hardcore. I have had a student last year that tried to do all the labs in command lines. It was great fun. Or it provides a graphical user interface in a website, a web page basically. And from there, you can manage hundreds or thousands of users just from this one place, and it's brilliant. So we will be using, for this unit, we'll be using VMware Workstation Player version 17 for Linux. So that's the first 2 weeks. The second 2 weeks we'll play around with VirtualBox 706. So these are the most basic ways that you can do, the most basic and easiest way that you can implement virtualization on any computer, even if it's not the strongest computer in the universe. So I'm starting you really slow and basic in this. Yes, some of you will have had network service and services or system administration and networking with me this year and last year. So this first labs, it should really be a breeze for you. Although it does get a bit complicated towards the end, but never mind. And we're comparing these two because these two are the biggest players in the simplest virtualization solution that you can provide in a company. So VMware has existed since forever, and it was one of the first, and VirtualBox just as much. Okay, so together with KVM and Zen, really they were like the first virtualization hypervisors, as we call them, that would allow you to start up virtual machines about 18 years ago, funnily enough. Yeah. And in the second part of the unit, so from week 5 onwards, we will deal with Nebula. Nebula that we will be using is version 6.2. And the reason for this is, it's up to version 6.6 now. There aren't too many differences, and basically there aren't enough differences in it to warrant us having to move on to Rocky Linux in the labs themselves, because 6.6 will not run on CentOS 7 that we're actually using in the labs. It is the last year that we're using it in the labs, so we are moving to Rocky 8.7 next year. And that's the reason why we're using Nebula 6.2. There are really no differences between them. I did build a machine with Rocky and 6.6, and everything that I want to do in the labs is exactly the same. So there was no point bothering my system administrators with updating the operating system on the host as well. Okay. Now, recommended reading. I hope you've all used Linux before. We're using CentOS, which is based on Red Hat Enterprise in the lab itself, and the virtual machines that you will build will also be CentOS 7. Okay, so there is a book that you can have about it if you like. There's also an electronic version that you can also find for free online if you look hard enough. And I have the manual pages for VMware 17, VirtualBox 7, and OpenNebula 6.2 on the links in this slide. So if you just click on the links, it will take you to the manual pages, and you can read all about the installation, basic management, and everything else that you might need to know about this module. Okay, any questions about all this? The number one most important thing is that you just come to the lab. Yeah, if you come to the lab, we'll help you, you can go through everything. I've had students in the past that have completed the lab sheets and have near zero understanding of what's happening. But hopefully they learned a little bit. Yeah? So we do tend to help out in the labs, so just make sure that you come on time in the lab because you only have 2 hours and there will be other sessions around those lab sessions, so you won't be able to stay longer usually. All right. And of course, come to the lectures so that I can explain the theory behind what's going on in the labs so that you have a much better understanding of everything that's happening. Okay. I will see you all next week. Thank you very much.